Hi, I've got one simplification topic that I didn't talk about earlier with radicals that might be kind of important. It's the idea known as rationalizing the denominator of a fraction. Okay, and if you're wondering what that means, let me try to explain. Basically, in the old days, people didn't have fancy graphing calculators, fancy scientific calculators that could give decimal equivalents of radicals. So what people actually had was tables that would allow them to look up square roots of values. Okay, so if you had something like 3 radical 2, you could look up the square root of 2 decimal on a table and you could multiply it by 3. Okay, the tables did not include division by square roots. And so as a result, it was considered to be bad form to have a square root in the bottom of a fraction. Okay, so while this isn't wrong, we have an irrational number. Okay, this is a decimal that would go on infinitely in the bottom of the fraction. It's not considered to be the best form for leaving a fraction. Okay, so the goal here is to get rid of the square root in the bottom of the fraction. And if you think about this, if you square a square root, you get rid of the square root symbol, basically. So that's what we're going to do. But the other thing here is we're working with a fraction. So you have to be really careful. I can't square the top of the fraction because the top of the fraction would be getting multiplied by 6 if I squared it. The bottom of the fraction would be getting multiplied by radical 3. If a fraction is going to keep the same value, you need to multiply the top and the bottom by the same thing. Okay? So I'm going to square the square root. Okay? Squaring the square root will multiply the square root by itself, but it's a fraction, so I have to multiply the top by the same thing. So on top, I'm going to get a whole number times a radical. That doesn't simplify it. On the bottom, radical 3 times radical 3 is radical 9, which is 3, or you can think of it as being the square root of 3 squared, which knocks out the square root. Okay? Check and see if the whole number divides into the whole number. You may be able to simplify it down. Remember that a whole number does not divide into a radical. So even if you want to do a radical 1 there, it's not how that works. All right? 3 goes into 6 2 times. You can write this as 2 radical 3. Okay? If you're not sure, check that decimal on your calculator. It'll be the same thing as the original 6 over the square root of 3 that we started out with. Okay? 2 more examples. So same thing here. We've got a square root in the bottom. Multiply the top and bottom by that square root. On top, you're going to get 5 radical 6. On the bottom, you're going to get 6. Again, this can't divide into a radical. 6 and 5 don't simplify. It's just 5 6. You could write it as 5/6 radical 6. That would be the same thing if you think about fraction multiplication rules. But this answer here is just fine. Okay? Now, the last example, if I multiply the bottom by the square root of 6 and the top by the square root of 6, you're going to get 10 radical 6 over 6. It is a fraction. Do check. If there's a greatest common factor that you can divide it out. So notice here, 10 and 6 are both divisible by 2. Okay, so 2 goes into 10 5 times, 2 goes into 6 3 times. You don't divide a whole number into a radical. Okay, it's just going to stay 5 radical 6 over 3, or you could write it as 5/3 radical 6. So I will ask, if you get a radical in a denominator, make sure that you get rid of that radical in the denominator by multiplying both parts of the fraction by that radical that's in the denominator. Okay, it's called rationalizing the denominator. We're getting a rational number in the denominator of the fraction instead of having an irrational number. Hope that helps.